So first of all, you're trying. What's your goal? Your goal is to have something x plus something times something x plus something else. And what do you know about these two first things? They have to multiply together to get 10. And then what do you know about these two? They have to multiply together to get negative 18. So you start with the purple and you say, like, what's a way we could break up 10? 5 and what?
2.
They multiply, so 5 and 2. What about negative 18?
6. Negative 6.
How about negative 6 and 3, like this? So at this point, what do you have to do? Are you definitely right? No, because you know that you're going to get 10x squared and negative 18, but you don't know if you're going to get 3x or not. So what do you have to do? You have to test it. Actually check it. You have to test this out. So you actually have to test this. So how do you do that? Well, what are you testing? You're testing 5x minus 6 times 2x plus 3. What's 5x times 2x? Oh yeah, that's great. What about, 5x times 3? What's 5x times 3? 15x. What's negative 6 times 2? Negative 6 times 3. So what do you end up with? 10x squared plus how much? How many? 3x minus. Did we get what we wanted? We did. So we get a smiley face. Now, if we had done it, let's say, so we did get the proper one. Let's say instead we did 5x plus 3 times 2x minus 6. That would fit the parameters, right? Because what's 3 times negative 6? Negative 18. What's 5x times 2x? But if we multiply this out, you end up with 10x squared minus 30x plus 6x minus 18. Do you end up with the same thing? No. So is this correct? No, it's not. You do the frowny face. But you get better at testing these as you practice them. You have to practice them. That's really the core thing for factoring. You'll get a sense. Like when I was doing this, I was like, oh, well, if I put the 6 here, it means it's going to get hit by the 5. And the center term, is 3 a big number or a small number? So I want to keep it small, so keep the 6 away from the 5, so keep it in the same term. So it just takes an intuition. So first of all, what's not the leading coefficient? What's not the leading coefficient? 42 is not the leading coefficient, but we want the leading coefficient we want. It's not. Is there anything we can factor out first? Is there any common term? No. So you have to break this up. Something x plus something times something x plus something else, right?
Is that like a concrete thing, like you can do that for every problem?
Yeah, sure. Absolutely. It's a trinomial, yeah. Absolutely. For any trinomial, you could set it up like that. Absolutely.
Wouldn't it be minus?
Well, you could put a negative in the slide. I'm just putting plus there. You could put a negative number there. So what do you know about these two numbers? They have to multiply together to get what? 27. And you know that these two numbers have to multiply together to get negative 5. 27, unfortunately, is kind of has lots of factors, 3, 3, and 3, 3 and 9, you know, but it's two numbers. So what two numbers do you want to try? Oh, let's try 9 and 3. And what about negative 5?
Negative 5, 1.
Yeah, let's put the 5 here and negative 1 right there. So what are we testing? 9x minus 1 times 3x plus what? 5. What do we get? 27x squared plus 45x minus 3x minus 5. Do we end up with what we wanted? Do we end up with what we wanted? We do. Now, let's say we tested something else, though. Let's say we tested 9x plus 5 and 3x minus 1. Not 5, 1. Are we going to get the proper answer? No. If we had started this way, we would have ended up, what, minus 9x plus 15x minus 5. What do you end up with? 27x squared plus 6x minus 5. Is that the right answer? No. So that's a frowny face, but this one is a smiley face. The reason I put the 5 here, just in terms of intuition, is the middle term. Is that 42 is a rather big number, right? We have to construct that 42. So I wanted I wanted the 9 to hit that 9x to hit that 5. It gets me almost there. So anyway, you'll start seeing these things and start feeling these things. I understand that you feel as though math should be a very kind of binary, algorithmic. You do this, then you do this. It's similar. There is an algorithm to it. You have to test pairs, and you have to keep track of those things that you're testing. But you will get better, and it will get faster as you practice these. Okay, another one. This one's annoying because all the numbers are what? All the numbers are pretty big. or relatively big. It's nice when they're smaller and have no factors and are prime. Unfortunately, it's kind of a pain. So this one again, what are you looking for? Something x plus something, something x plus something else. Well, 20, what are two numbers that multiply together to get 20? 10 and 2, 5 and 4. There's lots of options. What should I test? Anybody? 5 and 4? So we could try 5x and 4x. What are two numbers that multiply together to get 24? How about like 8 and 3? 8 and 3, like that? So let's test it. You get 20x squared plus 15x plus 32x plus 24. Oh, did we get the right thing from the immediate? Oh, look at that. Did we get it? Are there lots of other things we could have tested on this one, though? Yeah, instead of 5 and 4, it could have been 4 and 5, right? You can switch the order. Or it could be 10 and 2 or 2 and 10. What about 24? 2 and 12, 6 and 4, 3 and 8, right? So there are lots of different things. So you need to keep track of what you're testing, and hopefully you'll get better and better at this. So you look at that and you want it to be a difference of squares or difference of cubes, right? The problem is 32 a square number? No. Is 98 a square number? But both of those numbers are what? They're both what? No, 32 is not squared. C is, but what type of number is 32? What type of number is 98? They're both even. So what can you factor out of both of them? 2. You could, but hold on. You can't factor out an 8 because 8 doesn't go to 98. But you can factor out a 2, right? What do you get? 16 what? Minus 49. What do you now see? What is 16? What is this? Both of those are what? Squares. So this is now the difference of what? Difference of squares. Sorry about the highlighter. So what does that mean? It's 2 times 4c squared minus 7d squared. And do you remember that formula you're supposed to memorize?
Yeah.
X squared minus y squared is equal to what? Do you remember? X plus y times x minus y. There's your formula, right? So what does this mean this turns into? What does it turn into? 2 times c minus, or plus. You can do plus first. That's fine. Plus, correct, times. Yes, done. You've applied the difference of squares. You've applied that formula. Look, it is, here's the 4c right here, and where did that go? Right there. What about the 7d? There's the 7d right there. Does that kind of make sense? This one was a little tricky because do you see, are the squares obvious right there? Not really. But what's the first thing you always try to do? If I gave you something really big, you always try to pull out and make things smaller, right? You try to make things smaller. It's easier to factor smaller things. It's easier to factor smaller things. Okay, put everything away except the pencil, please. No. If I had this one, I'd pull out a 2 first. Actually, you could pull out something better. How about 10? 10, you get 126. You can, yeah. And then you can pull out a 2, and that's a 5, right? And this is 2, 63, right? And what's 63? 9 and 7. And what's 9? 3 and 3. So then once you're done, what do you look at? Yeah, you do. The numbers on the bottom. Right?
I got it wrong. Is it so embarrassing?
Oh, yeah, it does. It does. I missed the 7, yes.
I did it wrong.
I wrote 9 and 7.
So what does that equal? How many 2's do you see? How many 2's do you see?
2.
So it's 2 squared times 5 times 7. That would be the prime factorization right there. A little bit more fun because you need to be prepared to kind of see any type of general form. What I mean by that is it could start and be nice like this one. What's nice about this one?
It does not have.
It has a, yeah, it has a leading coefficient that is what? The leading coefficient is 1. That's wonderful. Then we can do the thing that Alyssa likes, which is you find two numbers that multiply together to get what? And add together to get? So you can only do this when the leading coefficient is 1. In this case, are there two numbers that work really nicely? 5 and? They have to 5 and 5. Oh, that's a nice one. So that's cool. We can ramp it up a little bit. We could change it into, how about y squared minus 5y minus 6? Again, though, the leading coefficient is 1, but we've added in some negatives. The two numbers we need to multiply together to get negative what? negative 6, but add together to get negative 5. What two numbers are those? Well, nope, they don't add together to get negative 5. Minus, I'll give you a hint, 6 and plus 1. They multiply together to get negative 6, and they add together to get negative 5. But can things get a little bit more challenging? Absolutely. You could end up with something like this. 49z squared minus 42z plus 9. You could end up with that right there. What is not so cool about this one? There's no what? There's no greatest common factor you can pull out. That's correct. The greatest common factor would be 1. So what's not nice is that the leading coefficient is not 1. So we have to break it apart like we were just practicing. So the leading coefficients in front of x need to be multiplied together to get what? Not x, sorry, z, sorry. What do the leading coefficients need to multiply together to be? 49. These two need to multiply together to get what? 49. We just did a bunch of those. And what do these two need to multiply together to get? 9. So what two numbers multiply together to get 49 really nicely? How about 7 and? What about 9?
Negative.
But it needs to be negative, so how about negative 3 and? So, because it has to be negative in the middle. What's negative 3 times? Because they need to multiply together to get 9, but we also have a negative number inside this trinomial, so somehow we have to get a negative in there. What's negative 3 times negative 3? So is it okay if we choose negative 3 and negative 3? Does that fit the rule, the product being 9? Yes. So we put negative in there because somewhere we need to generate a negative 42. So there needs to be a negative number somewhere. Can you multiply things together without negatives and get a negative? No, you have to have a negative in there somewhere. So what are we testing? Yes, just by knowing it. That is correct. Is this number negative?
Yes, I am. Yeah.
Therefore, I'm giving you the rule. Ready? I'm just giving you the rule. If that number is negative, somewhere in your factorization, there better be a negative number. Somewhere. So we just chose, how about negative 3 and negative 3? Because do they still multiply properly? Mm-hmm. But we have to test this. Does it work? What's 7z times 7z? Hey, that's good. And then you end up with minus 21z, and plus 9. So does this work? Is that what we wanted it to be? It is what we wanted it to be. So they get more entertaining. What, though, do you do when you're presented with something that looks like this? xy squared minus y cubed plus x cubed minus x squared y. What's your first thought when you see something like that? Well, is there a y in this? Yeah, it's 4 things. And what was that method we did when we had 4 things? Yeah. So one of the things you have is grouping. So you look at this and you say, is there anything I can do here? What do you think? Yeah, what do you think? Let's do this one right here. What do you want to take out from that one? You want to take out y? How about y squared? What do you get? X minus? And then you do, from this one, what do you pull out? Yeah, when you left. Good. Is that what you want to see? Yeah, you want to see this, because what can you now pull out of both of them? So you get x minus y times x squared plus, yeah, I'm putting it in alphabetical order. You could do y squared plus x squared, that's fine. The point is, when you see something like this, honestly, to be perfectly honest, even in my head, I think this. Right? But, if I give you something like this on a test, I'm not going to give you one that looks that ugly and have it be prime. If I give you one that's ugly, it's going to be factorable, okay? It's really mean of me if I gave you something that was ugly and it was prime. So on this one, when you see 4 terms, what's really the only thing you have if you have 4 terms? Really the only thing you have is grouping. Now, sometimes I might give you 4 terms, and can you combine things sometimes? Sure, but can you combine any of those terms? No. Yes, Nate? What did I get rid of it? Oh, sorry. Well, I didn't get rid of it. the y squared went, this y squared went right there. This x squared went right there. I didn't get rid of it. When you factor out an x minus y from this, what are you left with? Y squared. When you factor out an x minus y from there, what are you left with? X squared. So that's where they went. They are right there. And then what did we factor out? We factored out x minus y. So that's why the x minus y is right there. Cool. Can anybody tell me what you can do? Oh, what do you see right here? What is that and what's this? Those are both what? Squares. Yeah. This is, what is the square root of 4? This is 2k squared minus 3 squared, right? So that's the difference of what? It's the difference of squares. So what does this factor into? What does this factor into? 2k what? Plus 3 times 2k minus 3, and then what's along for the ride? 5k plus 1. This would be most of the credit. This would be complete credit right there.
Oh, so that has full credit?
Yes, for full credit. Yeah, absolutely. This would be like a 4-point question on a quiz. Yes, Jacob.
How did you get from the 2k squared minus 3 squared to
because you know that x squared minus y squared is equal to x plus y times x minus y. So we have right here a square and a square, the difference of squares. The difference of squares factors like that. Why does it factor like that? Because you end up with x squared minus xy plus xy minus y squared. What happens to the middle terms? They cancel out and you're left with just x squared minus y squared. So that's why this is true. That's true because when you multiply it out, they go away. So this right here, it's the same thing right there. This is just along for the ride at this point. This would be a 4 or 5 point test question. Yes. So this involves, look what this involves. This involves grouping, right? And then after grouping, what do you have to use? Difference of squares. 2 of them. That's 2 things. It's a lot. It is a lot. This is a great question. I really like that. Oh, great. Where did it go? Do you see where the window went?
No.
Oh, there it is, right there. Okay, good. It was paused. Excellent. It was hidden under the full screen. Anyway, it's similar to this. This is a different program that we might get for you next year. I have to get it in the school budget because this is like $50 per license. But this is a free way for you guys to do this, so please try it. Okay, so we have another 8 minutes, right? Because we're ending at 2:40, correct? 7 minutes. Ooh. So I'm going to give you a few problems to work on, okay? Here we go. How about you try...
Do you post all of the recordings on YouTube?
Which of the student ones? Not all of the student ones. Most of the student ones get uploaded, yes. Most of the student ones. Mm-hmm. Why not?
Why?
Why not?
To do during study hall?
To actually go to class? He's saying he watches my class during study hall.
He pauses your video, watches a different video.
Oh, yeah. Why do you say that out loud? Why? Why?
I still watch
I
the
didn't
video.
I
Finish it.
Great.
Study hall.
But I didn't watch the video, so I can see myself.
Yeah, I say that?
Yep.
Did you really just say that?
Pretend you did it.
Okay, kids, try those two. Go.
Why is there 6 and a D next to each other?
It's out of the way. What should I do first, Rachel?
Find the DCF.
Yeah, what did you pull out first? Let's just pull out 2 first. 128 times b squared minus 200c squared. What else can I pull out? Oh, another 2. Oh, another. Minus 100c squared. Oh, I just pulled out 2 and then 2 again. What did I end up with? That is difference of squares. Oh, wait, was it difference of squares to begin with?
Yeah.
What's the square root of 256? Oh, you figured it out already. So this is 16b squared minus 20c squared. So what's that going to be? 16b minus, oh, I got to put the b in there, right? times 16b plus 20c. There it is. Good job. That was great. So here's a key, kids. What are these? What are these? What are these?
Numbers?
Yes, correct.
Integers?
Those are squares. You need to recognize squares. What are these?
Fibonacci numbers.
No.
They're number 8.
What are they?
Oh, they're the one up from squares.
What is that called? Cubes. That's fine. You need to recognize them. So, Kelly, you recognized 256 as a square, and it was a pretty simple problem, right? Okay, what about this one? What do you do first on this one?
Do a line and X and then plus and then.
No, it's. What should I pull out? What can I pull out of all?
Square.
Yeah, so what do you get? You get 32 plus 16x minus 24 what? X to the... Now I can take... What else can I take out now? 8. So I take out 8, and what am I left with? 4 plus...
8.
Sorry, 4 plus 2x minus what? 3x what? Isn't it cubed? 3x cubed. Now here's the thing. This right here, isn't it cubed? Isn't it cubed? Isn't it cubed? Okay, at this point, you'd be done.